Hey guys, welcome to Technomzar. This is Rohit Sharma, and in this video we are going to analyze the quiz 8, which was based upon network theory as well as control system. Okay, total of 25 questions were present there and carries 100 marks. One correct question is equal to 4 marks and one correct is equal to 1 mark. Okay, those who want to attend the quiz, okay, so please join our group, Telegram group, ISRO for Easy, where we provide a link daily at 7 p.m. to attend the quiz, and many students are preparing with me. Okay, so let's start the quiz. Question number first. This is a little bit tough question. According to ISRO technical assistant students, those who are from diploma, according to me, this question will not come in ISRO, but I will tell you how we will do this question. Okay, when there is a negative slope, remember this: when there is a negative slope, there is a pole. Okay. And when there is a positive slope, there is a zero. Okay. Pole comes in denominator, we know this, and zero comes in numerator. Okay. Minus 20 dB per decade gives us one pole, that is S. Okay. And minus 40 gives us S square. Similarly with plus 20 gives us 1 as 1 0, and plus 40 gives us with 2 zeros. Okay, now see this figure. We are seeing this minus 40 dB per decade. Okay, minus 40 dB per decade, that means 2 pole at the origin. Okay, that is S square. Then minus 40 plus 20, then only we get minus 20. Therefore, there is a 0 at 4, that is 1 plus S up by 4. Okay, now minus 20 is minus 40. There is a pole at 10, that is 1 plus S upon 10. Okay, this is our G of S. Okay, now we have to find the steady state error at unit acceleration input. Okay, to find the steady state error at unit acceleration input, I am finding Ka. Ka is given as limit x tends to 0 S square G of S, that is equal to limit S tends to 0 S square K 1 plus S upon 4 upon S square 1 plus S upon 10. S square cancels with S square. We will come up with Ka is equal to K. Okay, therefore we know that ESS is equal to 1 upon Ka, and we know that 1 upon Ka is equal to 1 by K. Steady state error is equal to 1 by K. Now we have to find the value of K. Okay, now to find the value of K, we are saying this magnitude in dB at omega equal to 8. Omega equal to 8, magnitude is 0 decibel. Okay, so I can write this K upon S square at omega is equal to 8 gives us 1. Okay, which is equal to K upon 8 square, which is equal to 1. K is equal to 64. Therefore, steady state error is given as ESS 1 upon K, where that is equal to 1 upon 64 is the correct answer. Okay, therefore option C is the correct answer. Now next question, question number 2. The dominant pole of a control system are located at S is equal to minus 1 plus minus 2 J. The damping ratio, we have to find the damping ratio. Okay, so damping ratio, that is zeta, we have to find zeta, and from here we can find our omega n. Omega n is minus 1 ka square plus 2 square, that is equal to root 5. Omega n is equal to 5 and we know that zeta omega n is equal to 1 for dominant pole of a control system. Then omega n is equal to root 5. Zeta into root 5 is equal to 1. Zeta is equal to 1 upon root 5, and on solving this 1 upon root 5, and we know that root 5 value is 2.24. 1 upon 2.24 we will get here as 0.447 is the correct answer, option A. Next question. If the impulse response of the transfer function is h of t is equal to 2t e to the power minus 2t u of t, okay, the transfer function of the system will be, okay. So to find the transfer function, we know transfer function is equal to Laplace transform of impulse response. Laplace transform of impulse response. So e to the minus 2t is 1 upon s plus 2 into 2, that is t is 1 upon s square. Okay, therefore it will be 1 upon s plus 2 square and into 2 multiplied by the constant. Therefore transfer function will be 2 upon s plus 2 ka whole square. This is equal to 2 upon s square 4s plus 4. Option D is the correct answer. Next question. For the control system, the approximate value of beta to make the damping ratio of the system equal to 0.5. That is, they have given us zeta is equal to 0.5 and we have to calculate beta. If we find the transfer function from this block diagram, we can easily calculate our beta. Okay. First, this is a closed loop system. We can find, and it is negative feedback. For negative feedback, the transfer function is gs upon 1 plus g of s. Okay. From here, we will get, on calculating here the open loop, the closed loop transfer function, we will get 5 upon s square plus 2s plus 5 beta s. Okay, 5 beta s. We will get this as transfer function. Now I am multiplying this by 2 because they are in product form. 5 into 2. That will be equal to 10 upon s square plus 2 plus 5 beta bracket s. Now whole this is also a closed loop transfer function. Now recalculating our transfer function, that is g of s upon 1 plus g of s. Okay, we will get 10 upon s square plus 2 plus 5 beta s plus 10. This will be our transfer function. If we are comparing this by our standard transfer function equation, that is omega n square upon s square plus 2 zeta omega ns plus omega n square. From here I can write this omega n is equal to root 10. Okay, on comparing these two equations, and 2 zeta omega n is equal to 2 plus 5 beta. We know that zeta is equal to 0.5 and omega n is equal to root 10, which is equal to 2 plus 5 beta. From here beta is equal to root 10 minus 2 upon 5. Approximate value will be 0.232. Okay. Option A is the correct answer. Now next question. Question number 5th. Consider a first order circuit with a single resistor. If the resistor value is halved, the time constant becomes doubled. Simply, we know that time constant is given by L by R, or if it is a RC circuit, then time constant is equal to RC. Now they have said the resistor value is halved, that is 1 by half, 1 by 2R. Okay, this will be equal to twice of L by R हो गया, ठीक है. Now for this resistor value is half, R by 2. Now in this the time constant gets half, but in this the time constants get double, and we have to say in which circuit we will get the time constant as double. In RL circuit we will get the time constant as double, that is 2L upon R. Okay. Question number 6th. This is a network theory question. Consider the circuit shown in the figure below. If the Thevenin equivalent resistance is given as, that is RTH is given as 4 ohm. We have to find R. Okay. To find RTH, we turn off all the independent sources, that is voltage sources replaced by short circuit, that is this will be 2 ohm. This will be open circuit 1 ohm. This will be 2 ohm, 2 ohm, and this is R, and this is 1 ohm. Okay. From here we can calculate our RTH. 2 parallel 2 is 1, and 1 plus R plus 1 is equal to RTH, and RTH is given as 4 ohm. Therefore R is equal, this is R plus 1 plus 1, R is equal to 4 minus 2, that is R is equal to 2 ohm will be the correct answer. Option B. Next question, question number 7. The maximum value of mutual inductance of two inductively coupled coil with self-inductor, that is L1 is equal to 36 millihenry and L2 is equal to 9 millihenry. We know that M is equal to K root L1 L2. Okay. For maximum value K is equal to coefficient of coupling will be 1. Okay. Therefore root of L1 into L2 On calculating this, we will get 36 into 10 to the power minus 3 into 9 into 10 to the power minus 3. Okay. This will be root of 36 into 9 into 10 to the power minus 3 will get outside from the root. Root 36 into 9 will be root 324 into 10 to the power minus 3. 18 square is 324, therefore answer will be 18 into 10 to the power minus 3, that is equal to 18 millihenry will be the correct answer. Option C is the correct answer. Next. In a series RL circuit, the R equal to 20, L is equal to 60 is the current lags by voltage. Okay. Now we know that tan theta is equal to omega L upon R. Tan theta is given as theta is equal to 60. Tan 60 is equal to omega L. L is 60 millihenry, that is 10 to the power minus 3 upon R is 20. Tan 60 is given as root 3 omega 6 upon 2 into 10 to the power minus 3. 0 0 get cancelled. Now on finding the value, we will get 2 into root 3 upon 6 into 10 to the power minus 3. This 3, okay, this will be equal to 1 upon root 3 kilo radian per second. Option A is the correct answer. Next question. Addition of pole to the forward path gain. Addition of pole always decreases our stability if we talk about an S plane, sigma, j omega. This is RHS and this is the LHS side. When all the poles are at the LHS side, then the system will be stable. If it is on the RHS, then it is unstable. But after adding a pole to the forward path gain, the system transfer function, the pole, the stability moves towards the RHS. The stability moves towards the RHS. Therefore, by adding a pole, the stability reduces. The stability reduces. If the stability reduces, the steady state error also is reduces. Okay, option A is the correct answer. Question number 10. The unit step response of particular, okay. We have to find the transfer functions. We know that C of t is equal to 1 minus 5 e to the power minus t dt. Okay. On finding the Laplace transform of this, that is C of s, we get one Laplace transform of 1 is 1 upon s, and the minus 5 e to the power minus t Laplace transform is minus 5 upon s plus 1. Okay. On solving this, taking LCM, s plus 1 minus 5s. Okay. We will get 1 minus 4 upon s into s plus 1. And we know that transfer function is given by C of s upon R of s. And R of s is 1 of s because it is a unit step function. C of s is 1 minus 4s upon s into s plus 1 upon 1 by s. From here we will get 1 minus 4s and s into s plus 1 into s upon 1. S get cancelled. The transfer function will be minus 1 minus 4 upon s plus 1. Therefore, option C is the correct answer. Question number 11. The closed loop system with loop transfer function, that is given as s plus 2 upon s square bracket s plus 1. Okay. Here you should see the power of s. The power of s is 2. Therefore, it is a type 2 system. Okay. On multiplying the denominator, we will get x cube plus s square. Therefore, the order is 3. Order is 3. Order of the system is 3. Therefore, option C is type 2 and order 3 is the correct answer. Question number 12. The characteristic equation of a closed loop system is this: s plus 1, s plus 2, s minus 3 is equal to 0. We have to find the system is stable or not. I have said that if any pole or 0, if any pole lies in the RHS, the system is unstable. If it is in LHS, the system is stable. If it is on the imaginary axis, the system will be marginally stable. Okay. Now, here one pole is at minus 1, that is at LHS. One pole is at minus 2, that is also in LHS. But one pole is at s equal to 3, that is in RHS. If any pole is in the RHS, then the system will be unstable. Therefore, option C is the correct answer. Next question. Okay. The loop transfer function of the negative feedback system is given by okay. Always remember there, if a transfer function is there will be equal number of poles and as well as equal number of zeros. Okay. Pole is shown by denominator and 0 is shown by the numerator. Okay. Now total pole here is s plus 1. From here one pole is there, and if this is a quadratic equation, there will be 2 poles. There are total number of 4 poles, okay, and total number of zeros is 1. If we subtract p minus z, that is 4 minus 1, that is equal to 3. There will be 3 zeros at infinity, because I have said there are, if there are equal number, if there are 4 poles, then there will be 4 zeros, okay, according to the transfer function, open loop transfer function of a negative feedback system. Therefore, if 0 is 1, pole is 4, then 3 zeros are at infinity. Option C is the correct answer. Question number 14. This is a good question. G of s is given as 1 upon s into s plus 1. From here, first we find a transfer function. Transfer function is given as g of s 1 plus g of s h of s for a negative feedback system. Now 1 upon s into s plus 1 upon 1 plus 1 upon s into s plus 1. On calculating this, we will get 1 upon s into s plus 1 upon s into, taking LCM here, plus 1 s into s plus 1. Okay, cancelling it, we will get the transfer function as s square plus s plus 1. Okay, from here we will calculate our, comparing this by our standard equation, omega n square upon s square plus 2 zeta omega ns plus omega n square. From here we will get omega n as 1 and 2 zeta omega n is equal to 1, and zeta from here we will get as 0.5. For settling time for 2% tolerance, the settling time Ts will be is equal to 4 upon zeta omega n, and zeta is 0.5 and omega n is 1. 4 upon 0.5 is 8 seconds. Therefore the settling time will be 8 seconds for 2% tolerance bend. Option A is the correct answer. Question number 15. The terms in the first column of a Routh array of a characteristic equation of a certain system are 6, 7, 4, minus 4, minus 3, minus 4, minus 5. Okay. The number of roots of the characteristic right half. The number of roots that lies in the right half. Okay. So one property is there. The number of sign changes. The number of sign changes represent the poles in the right half. Okay, you can see there is only one sign change between this. Okay, therefore one pole will be there in the right half of S plane. Okay, one root will be there. Option A is the correct answer. Question number 16. Okay, the voltage V of x across the 2 ohm resistance. We have to calculate the voltage across 2 ohm. Now I am calculating the node voltage here. So applying nodal analysis, V upon 5 minus 10 plus V minus 40 upon 5. Okay, taking LCM here, I am taking 10 here, V upon 5 plus V minus 40 upon 5. This is equal to 2V minus 40 is equal to 50. V is equal to 45 here. If V is 45, I can find the current here. If V is 45 volt here, I can find the current through this. I is equal to 45 upon 5, 3 plus 2, 5, that is equal to 9 ampere. Now we have to find Vx. Vx is equal to 2 into 9, that is equal to 18 volt. The voltage across 2 ohm is 18 volt. Option C is the correct answer. Next question, question number 17. We have to find the current I1. Okay, applying nodal here, same as above question, V minus 250 upon 2.5 plus V by 10 minus 5 I1. I1 can also be written as 250 minus V upon 2.5. Okay, putting this here, 250 minus V upon 2.5 is equal to 0. Okay, taking LCM will come out to be 10. This will come out to be 4V minus 1000 plus V minus 5000 plus 5 for 20V. 20V is here. Okay, so 4V, 5V, 25V is equal to 6000. V will be 6000 divided by 25, 0. On calculating this, we will get 240 volt. current I1 is given as 250 minus V upon 2.5. Therefore, 250 minus V is 240 upon 2.5. That is equal to 10 upon 2.5, which is equal to 4 ampere is the answer. Current I1 is 4 ampere. Next question, when a source is delivering maximum power to a load, we have seen this question many times. Also, I have given this in the last quiz also, and I have given in two or three times I have given this question. When a source is delivering maximum power to a load, the efficiency of the circuit is always 50%. Remember this. Option is the correct answer. Next question. A source RLC circuit has a resonant frequency R, L or C. We have to find the new resonant frequency. Okay, we know that omega naught is equal to 1 upon root LC. Now new resonant frequency in which all the values are tripled. Okay, so for the old resonant frequency root 1 into 1, the omega naught will be 1, that is equal to F, or you can say root LC. 1 upon 3 times of L, that is 3 into 1, 3 into 3. This will equal to 1 upon 3, that is F by 3. The new resonant frequency will be F upon 3. Therefore, option D is the correct answer. Next question. For a RLC series circuit in resonance, the following statement is not correct. In resonance, we know that VL is equal to VC. We know this, but they have said the voltage drop across the capacitance and inductance are unequal. They are equal for resonant condition. Therefore, this is wrong. Option D is the correct answer. Question number 21. What does the function f of t plotted in the figure? This is an impulse function. Okay. Unit step is like this. Unit ramp is like this. Okay. Therefore, this is unit impulse function. Option B is the correct answer. Next question. With negative feedback. Always when a negative feedback is produced in a system, the system stability increases, but the system gain decreases. Okay. Remember this point. Question number 23. Question number 23 is given as the steady state error due to a ramp input for a type 2 system is given as, I am preparing one table here, type 0, type 1, remember this table, type 2. Okay, this is step, this is ramp, parabolic. For step type 2, type 0 system, the steady state error is given as A upon 1 plus K. For type 1, A upon K for ramp, and for parabolic type 2, A upon K. This all are infinity. This is 0. Okay. What they have asked, the steady state due to a ramp input, type 2 system, that is type 2 ramp input. This is equal to 0. Therefore, option A is the correct answer. Next question. The damping factor of the system is unity. Unity, whenever the damping factor, that is zeta is equal to 1, the system is critically damped. Okay, for underdamped, the zeta is between 0 to 1. For overdamped, zeta is always greater than 1. For undamped zeta is less than 0. Okay, remember these points. Last question, question number 25. I have given in answer key I have given the wrong answer. For this, the answer will be L and C. The resonant circuit always contain L and C, the inductor and capacitive element. Here I have completed the quiz analysis, or total 25 question I have explained in detail to you. If you have any doubt now, please you can ask me in the comment section, YouTube comment section, or in the Telegram group. And please join the Telegram group for attempting the quiz. And one important thing, please like the video if you like, and share the video to your friends, and don't forget to subscribe the channel. Okay, so all the best, मिलते हैं next video में.